Welcome back to my YouTube channel. Today we want to look at inclined plane, and we want to look that by the aid of an example. I want to remind you that you can subscribe to my YouTube channel, you can like and share my videos. The question reads, the figure below shows an inclined plane of length L and height h above the ground. This is the figure. We have L, that is the length of the inclined plane, and h, and we have an angle here, theta. Determine the velocity ratio and mechanical advantage in terms of sine theta. Assume no friction occurs. We know that velocity ratio VR, which we normally denote as VR, equals to effort distance or over load distance. So this is effort distance or over load distance. But in this case, our effort distance is L. You can say L or over load distance. The load is moved from here to here, which is given by H. But from mathematics, we know that sine theta, that is from trigonometry, sine theta equals to opposite, and our opposite side is H, or over hypotenuse, which is L. So this implies that our H is the same as L sine theta. So we can substitute here and say VR, that is velocity ratio, is equal to L over H, but our H is the same as L sine theta. L and L will cancel out, and we will have VR is equal to 1 over sine theta, and we have obtained velocity ratio in terms of sine theta. Also, we have been told that there is no friction. Assume no friction. That implies that our efficiency is equal to 1, or mechanical advantage is equal to VR, which is the same as 1 over sine theta. I mean, N is equivalent to 100%, that is velocity ratio efficiency. So mechanical advantage is the same as VR, which is the same as 1 over sine theta, because there is no friction. Part B of the question, a barrel is rolled up a lamp 6 meters long. The barrel weighs 400 newtons and is displaced through a height of 1.5 meters. If a force of 120 newton is applied parallel to the inclined plane, calculate the useful work done. So useful work done is the work done on the load, so that will be equal to work is the same as mgh, because the load is lifted some height from the ground. Therefore we can say mg, our mg is the weight, and the weight of that is equivalent to 400 newtons. So 400 newtons times the height in which it is lifted, they have said is the barrel weighs 400 is placed through a height of 1.5, so there's 1.5, and that will give us 600 joules. Roman 2, work input. We are supposed to find the work input. So how do we find work input? Work input is the same as work done by the effort, and the effort applied is 120 newtons times the distance moved by the effort from here up to there. So the effort distance is 6 meters. So that will give us 720 joules. Next, work needed to overcome friction. Work needed to overcome friction is just the difference between work input and work output. So that will give us the work input is 720 joules minus the work output is 600 joules. That will give us 120 joules. Efficiency. The last question, efficiency of the machine. We know that efficiency, to find efficiency, is given by work, the useful work, or we call also work output, or over work input times 100. So that will give us useful work, or the work output is 600, or over work input is 720 times 100%. So our efficiency will be equal to 83.33%. Thank you guys for watching my YouTube channel. If you like my videos, you can subscribe, you can like my videos, and also you can share my videos. Thank you for watching.